All right. So I asked for the warm-up, I asked you to solve, right? Both situations we're going to square root. How do we know we're going to square root these? Because a lot of times I'll give you like, here's 10 problems where you're doing the same thing, and here's 10 problems where you're doing something else. But on a test or when you get a worksheet near the end of the unit, it's just going to be a problem, and you got to remember which one it is. So if I was just looking at this in a mix of a bunch of problems, how would I know that I'm square rooting here? That's my strategy? Well, so is standard form. Standard form has a square, but I would never square root standard form. Because standard form, remember, is y equals ax squared plus bx plus c. I would not square root that. Go ahead. It doesn't have this. It's missing its bx term. So this is a missing bx term, and you want to be able to identify that. Missing the bx term. And that's why we know we can square root it. Okay, what about that one? Why do I know I can square root that one? What tells me that? This one. Second one. This one we square root because it's missing the bx term. What type of problem is this? It's vertex form. Whenever I see vertex form, I can square root. All right, so we want to be able to identify those out in the wild, right? Oh, that's a vertex problem. Oh, that's a missing bx problem. Yeah?
How do we know if the first one isn't vertex?
Well, you could make it vertex. But in its current form, you would need x plus 0 for it to be vertex, right? Which I know would simplify to that. I would say, to answer your question, think about it whatever way helps you the best. Yeah. But yeah, it's a good point. All right, so for any of these problems, what's the first thing we do? We set y equal to 0. Really? Right? You know? Right? Yeah. 0 equals 4x squared plus 36. Yeah. So now, what's my strategy before I square root? There's something we have to do.
You gotta put the number on the other side.
You're describing steps as part of the strategy, but what's my goal? To get the x squared by itself. We say isolate the square. Get it by itself. Whatever is being squared. And what's being squared here? Just x squared. This is the square. That's what I want to be by itself at the end of this, right? And by itself, I mean on this side of the equation. So that means that's got to go and that's got to go, right? So what's going to go first? Yeah, we add or subtract first. So I'm going to minus 36 and minus 36. I get minus 36 equals 4x squared. Now I can tell you a mistake that a lot of students might make at this point. Oh, it's by itself now. I can square root now. Why are you shaking your head no? Yeah, it's not by itself. It doesn't have a plus or a minus, but that's not by itself. There's still a 4 there, so I got to divide by 4. And I get negative 9 equals x squared. Now, at this point in the problem, hopefully, if it hasn't happened yet, hopefully at some point in this unit, alarm bells will go off in your head. You will know what type of problem this is, what type of answer you're going to get. Why? What's that? It's a negative on the other side. Think about what it means to square something. When you square something, what is your answer always? Something times itself will always result in what type of number? A positive number. This is already false. You're telling me there's a number that if you square it, you get negative 9. No, that's not possible, right? So making predictions in the middle of our problem helps us justify our answers in the end, right? So it's always good to do that. Question?
Can you square odd numbers?
Can you square root? Yeah, 9, 25, 49. Yeah. All right, so but that's our inclination. This is the proof, right? When we go to solve. So how do I get this by itself?
You make it.
How do I get x by itself if it's x squared?
You have to square it.
So you got to square root it, and I get x equals the square root of negative 9. And this is where our last lesson comes into play, because at this point we were stuck, but now we know what to do when we get a square root of a negative. What do? This was our... Yeah, I is going to get involved, right? So what do I change this to? Yep, square root of 9 times the square root of negative 1. Because now I can do some work. What's the square root of 9?
3.
What's the square root of 9? Plus or minus 3. And what's square root of negative 1? I. So here's my answer. Now, question. How many solutions are there to this problem? How many? Who says 2? Who says 1? Okay. What does it mean when we write the symbol plus or minus?
Positive 1,
It could be both. It's 2.
There's two different situations going on here. And I've asked every class that today for a reason. We write plus or minus so often because it's useful. You don't have to write the same thing twice. You can just write plus or minus. But we write it so many times that we get thinking that's just the one thing. It's just plus or minus. Remember what plus or minus means. It means plus or minus, meaning our two solutions here are x equals 3i or x equals negative 3i. That is two solutions, two answers. Now, I want you to get used to answering this question. The question is, what type of solutions do we have and how many do we have? We just talked about how many we have, which is what? 2. And what type do we have? What is I? An imaginary number. So we have 2 imaginary solutions, and then there's another question you want to be able to answer. What is the graph? What's going to be significant about the graph?
It's not going to have X-intercepts.
No X-intercepts. No X-intercepts. So I haven't even looked at the graph, thought about what the graph might look like, but I know something about it. I know it can't have X-intercepts because it doesn't have a solution. And we're going to kind of drill into why in a little bit. But think about the original equation. 4x squared plus 36. If you just sketch that real quick, right? Well, plus 36 would move you up a lot, right? And it doesn't flip down, so it would just be going up forever. Does that going to have any X-intercepts? No. So it makes sense that we didn't get an answer that made sense. Because we were trying to find X-intercepts and there were never going to be any X-intercepts. Okay? Questions? All right, let's look at vertex form. So, first step is always what? Make it equal 0. Y is 0. Negative 3, x minus 5 squared minus 12. Now, just like in the last problem, what's our goal? Isolate the square. But what's the square here? Last time it was just x. X minus 5 is the square, right? This is what's being squared. I know that's kind of a rectangle, but you get the point, right? That's what we need to get by itself. So everything else needs to go away. So what's the first thing that's going to go away?
12.
Right, so we would add 12 to both sides. And we would get 12 equals negative 3 times x minus 5 squared. Now, it's not by itself, right? There's what's in front of it? Negative 3. What is that negative 3 doing to the parentheses? Multiplying, right? You got to recognize that because we always do the opposite. If you don't know what's happening, you can't do the opposite. What's the opposite of? Division. Yep, division. So I got to divide negative 3, and I get negative 4 equals x minus 5 squared. Okay, again, maybe some alarm bells. Wait a minute, I'm squaring something and I get a negative? I don't think so. I think I know what my answer might look like. But let's prove it. So we square root, and we get x minus 5 over here, and then the square root of negative 4 over here. Square root of negative 4, we know becomes what?
4.
Yep, square root of 4 times the square root of negative 1, which is, square root of 4 is?
Negative
Plus or minus 2. And square root of negative 1 is I. So our answer is plus or minus 2I equals x minus 5.
But then you have to do the transfer.
Right, we're not done, right? Because what were we trying to find? When we're solving these, we're trying to find x. Is x by itself? No. So there's one more step to get x by itself.
You gotta add 5.
Add 5 to both sides.
Would that make it plus or minus 7?
Good question. All right, so now I have x equals, I'm just going to write them out, right? 5 plus or minus 2I, right? And you're saying plus or minus 7I maybe?
Yeah.
If you had 5 plus 2x, would you say that's 7x?
No,
No, why not?
because they're not the same variable.
They're not like terms. So are these like terms?
No,
No.
it just stays like
So
that.
it just stays like that. That's your answer. How many solutions do we have? 2. Can somebody name one of my solutions?
5 minus 2.
5 minus 2i. What's my other solution?
5 plus 2.
5 plus 2i. 2 solutions, right? 2 imaginary solutions. How many x-intercepts would this graph have? None. No solutions that are real, you don't have x-intercepts. Okay? So try to connect those dots as you're doing, even if you're just doing the algebra. Think about the graph. Question?
Will you square root x minus 5 squared? Like, you know that it's just x minus 5. Like with every...
So if you have something that's squared, right? And then you square root it. Well, think about what a square root is asking. It's saying, what times itself would give you that? Well, what times itself would give you x minus 5 squared? X minus 5 times itself would give you x minus 5 squared. So that's the result. Yeah, good question. Okay, all right, so let's summarize our kind of takeaways about x-intercepts, imaginary solutions, and then we'll practice, and then you'll have some time to work yourselves on some practice problems, and then we'll be done. Okay, so let's talk about imaginary numbers and solving specifically, right? Solving using imaginary numbers. Okay, so imaginary numbers. Here's the deal. A quadratic has 2 imaginary solutions anytime you square root a negative number, right? 2 imaginary solutions anytime you square root a negative number in your solving, right? And we know that that means something. What does that mean about the parabola? When there's no x-intercepts. That always means there are no x-intercepts. So it's one of a couple situations, right? It's either you got this situation where it just never gets there from the top, or we got this situation where it just never gets there on the bottom, right? But either situation, there are no x-intercepts. Now, the question I want us to answer before we move on is why? Why can we not, why is this just a coincidence that every time we don't have x-intercepts, we get a false solution? Or is there something about the graph that makes sense with this? There's some reason why we keep getting negative answers under radicals every time we try to solve one of these when there's no x-intercepts. Why is this not working? Why are we not getting a solution? Yeah?
If the parabola never passes the x-axis, there can be no answer.
Correct, but why? Think specifically about our equations. Why can't there be an answer? Why isn't anything make it true? You're right on target. Why couldn't it be true? Like, think back to this equation, right? we set it equal to 0, and then we try to find the x that made that true. Why can't that be true? Why is there, it turns out there's no x that can make this true. We couldn't find a solution. Why not? What's the first thing we always do? Set what to 0? Y. When we set y to 0, what we're asking ourselves is, hey, what's the x when y is 0? Right? What's the x when y is 0? Well, where is y 0 on each of these graphs? Where is y always 0? Y is positive up here, it's negative down here. Where is it 0? On the x-axis, right? So when you set y equal to 0, what you're asking is, hey, what's the x value when y is 0? Look at this graph. It comes down. Does it ever get to a y of 0? No, it gets down to, I don't know, 5 and then keeps going back up. This one, does it ever get to a y of 0? No, it goes up to like negative something, and then it never gets to y equals 0. So when we set up y equals 0, we were setting up a false equation. We didn't know it yet, but we were saying to ourselves, hey, when is y 0? And our answer was never. Like, it's never 0. It doesn't get there. That's why you don't get a real solution. The equation will never work. There's no x that makes it true. And that is what we want to take away here. So when you set y equal to 0, you solve for x when y is 0. No x-intercepts means y is never 0. Right? There's no x that would make it true. So how could we get a real solution? Yes, redefine mathematics. Right? So it makes sense that we keep getting these imaginary numbers because we set y to 0 and it's not. Okay. All right, so what we're going to do now is we're going to go through examples of square rooting like the warm-up, but some that get a little trickier. Okay? In each section, I'll go through an example with you, and then you will do the other ones, and then we'll circle back, and you can ask questions while you're working on them and stuff like that. Okay? So, anybody still writing? Yeah. All right. Are we ready? Okay. All right, so first example, again, is going to be our missing bx situation because that's when we would square root. The first thing we do is we set y to 0 because we're looking for the x-intercept. Negative 2x squared minus 8. Now, we want to isolate the square just like in our warm-up. So, what do I do? Plus 8, plus 8. I get 8 negative 2x squared. What else do I do? Divide by negative 2. I get x squared equals negative 4.
Are we always going to get a negative, or is it
When it's imaginary, yeah. Yeah. I mean, always going to have to square root a negative and imaginary. Yep.
So would it be
Because imaginary numbers happen all the time in advanced math, and they would grind problems to a halt if we couldn't keep going. This allows us to keep going and eventually get back to real numbers. And like we were talking about this last class, like Wi-Fi, cell towers, measuring the waves of light, like that's all requires imaginary numbers. So it's really important to science. All right, so this becomes x squared equals square root of negative 4, which, I'm sorry, not x equals the square root of negative 4. And then what happens?
then you take it away?
Yep, so x equals square root of 4 times square root of negative 1. X equals plus or minus 2i. And how many solutions do we have and what type? 2 imaginary solutions. What are the 3 possible solutions and types? Yep.
Positive, negative,
No, I mean like in terms of the number of solutions you can have and the type. There's 3 possible scenarios.
0. Intercept, standard, or
0 real, meaning 2 imaginary. That's our first one. You can either have 2 imaginary solutions, 2 real solutions, or, well, no solution's imaginary. 1 solution, 1 real solution. Remember if it was just like right on the axis, that's 1 solution and it's real. So that's your 3 scenarios: 2 real, 1 real, 2 imaginary. Okay, it's going to be one of those 3. Okay, make sense?
Say that again? 2 real?
Okay, let's sketch this out. Okay, you can have 2 real numbers as your solution, like 2 X-intercepts, right? You can have 1, so maybe it's just touches the axis and bounces off. That's 1 solution, and it's real. Or this other scenario that we're talking about today, you have no real solutions, 2 imaginary solutions. Those are your only possibilities. You're never going to have 1 imaginary solution. It's always a plus or minus. Okay? All right, so here we go. That one's solved. You do number 2, and then we'll come back together. Okay. All right, so there's some interesting questions, and I heard people saying, hey, I did it one way, she did it the other way. And some people even asked, like, wait, do I have to get it equal to 0? So here's my answer. There's a lot of students that, like, until it's equal to 0, they can't identify the situation and they don't know what to do. So if you want every time to just be comfortable with knowing that it gets equal to 0 every time, then do that. Set it equal to 0. All right, so as I was saying, if you're only comfortable once it's equal to 0, set it equal to 0. Plus 62, plus 62, right? That gives me 3x squared plus 60 equals 0. Now, this is where you might feel like, well, why did I just do that? Because now what's the next thing we need to do? Subtract. We gotta move the 60 back, right? So we gotta now move the 60 over here and to get 3x squared equals negative 60. So it might feel silly, we moved it and then we moved it back, but if that's what you're comfortable with and that's what allows you to enter the problem, do it. Like, get it equal to 0 first, feel comfortable, and then you'll know what to do. If you were already looking at this and knowing that you were going to be moving stuff away and you just wanted to add 2 to get started, you would have got the same answer. Okay? All right, so then we divide by 3, divide by 3. I get x squared equals negative 20. So I square root, I get x equals square root of negative 20. This is one of those ones maybe you take over to the side because you're like, square root of negative 20, I might be able to do something with that. Well, first of all, we know that we can always at least pull out the negative. So this is the square root of 20 times the square root of negative 1. But 20 is a number that's big enough, we want to try to break into it a little bit if we can. And I ask myself, I look at my perfect square list and I say, hey, any perfect squares go into that? 4. And then that's 4 times 5. So I'm going to replace this with square root of 4 times the square root of 5 times the square root of negative 1. Why did I do that? I can do the square root of 4, right? So, yeah, so this becomes plus or minus 2i square root of 5, right? That's what square root of negative 20 becomes. Do we see that? This becomes plus or minus 2. This becomes I. Nothing you can do with square root of 5. The I comes out front, kind of, front of the radical. All right, so x equals plus or minus 2i square root of 5. Questions?
just like that.
Oh, wait, I got a question.
Yeah.
On a test, like, you know how you, like, got 0? On a test, if you put 0 in the front, it's like you did 0 equals 3x squared plus 60.
Oh, So you're saying, like, you got to this point, and you're just like, I like the 0 in the front. And you just said, I'm going to rewrite this as 0 equals 3x squared plus 60, because that's what I'm comfortable with. Yep, that's fine. Highly recommend whatever you're comfortable with. Because you're used to having y over here, right? But you might see on either side, so you got to be prepared for either side. Okay, let's talk about vertex form. I will do one with you, and then you'll be off to the races. Okay, here we go. 0 equals x plus 4 squared plus 36. Trying to get that x plus 4 squared by itself, so I minus 36. This is going to be a friendly one, as friendly as these get. Minus 36 equals x plus 4 squared. Now, what do? Square root, square root. I get x plus 4 over here, and then over here, square root of negative 36. What is that?
6 square root x square root.
So square root of 36 times square root of negative 1, which is plus or minus 6i equals x plus 4. Now, do I have x by itself yet? No, I want x by itself, so I'm not quite done. I did the hard part. This is the easy part, but don't forget to do it. I have to subtract 4, subtract 4. Now, your answer is x equals negative 4 plus or minus 6i.
Oh, the 4 stays over there?
Yeah, you can't combine those two. It's not 2i, and it's not just plus 6i. It's plus or minus. Yeah.
So with I, is it the opposite of x where you put I at the end?
Yeah, and it's on purpose because they don't want people to get confused with the x situation. Questions? Other questions? How many solutions do I have?
3 through 2.
2. There's never 3. Not for these. And then what type of solutions are they? Imaginary. Can somebody tell me one of my solutions? Just one? Negative 4 plus 6i. Somebody else tell me another one.
Positive 4 plus.
No, that's still negative 4. That's not plus or minus. Negative 4 minus 6i. Yep. Okay, try the other two. All right, so for this one, set it equal to 0. Now, what's tricky about this one, and it is something you might see on a test or a homework. In fact, I know you'll see it on the homework. Is you're trying to get the square by itself. So you minus 3 from both sides. And then you get minus 3 equals 1/3 times x minus 7 squared. And then you're like, well, how do I get rid of that 1/3? Anyone know? How do I get rid of a 1/3 in the front? That's one thing you could do. What's the 1/3 doing? It's multiplying, so you could divide by 1/3. No, not here. And then when you put this into your calculator, you would do negative 3 divided by parentheses 1 divided by 3. You got to include those parentheses, or it will think you're doing negative 3 divided by 1 divided by 3, which is different. Make sure you put in parentheses. So that would give you your answer. The other thing you could do is you could say, well, 1/3, how do I just get rid of a 1/3? Like, what would make the 1/3 turn into 1? Multiplying it by 3. So you could also multiply by everything by 3, and then you would get the same result, which is negative 9 equals x minus 7 squared. And then you would square root. You'd get square root of negative 9 equals x minus 7. This would become plus or minus 3i equals x minus 7. And if you have to take that over to the side to figure that out, that's okay. I'm just want to get through these before the end of class. Plus 7, and our answer is x equals 7 plus or minus 3i, and you have 2 imaginary solutions. Any questions? Yeah? So I wanted the 1/3 to go away, right? Well, 1/3 times 3, how do I do that? I put that over 1. That's 3 over 3. That's 1. So multiplying this times this makes it 1 times that, which is just that.
Oh.
Yeah. If you want to just divide by 1/3 because that makes more sense, that's fine. All right, last one. All right, so here, again, we set it equal to 0. I isolate the square, so I move the 54, minus 54, minus 54. I get negative 54 equals 3 times x minus 1 squared. I still need to get rid of that 3. I can't distribute it, right? I cannot distribute this 3 with the squared, so I need to get rid of it. Divide by 3, divide by 3. We have about 5 minutes left. It's not time to pack up. So that's negative 18 equals x minus 1 squared, square root, and I get x minus 1. And then to find out square root of negative 18, I am going to take this over to the side. Square root of negative 18. What would I do with that? So that's the square root of 9 times the square root of 2 times the square root of negative 1. Right? Just pull it apart. You can do that in steps or all at once. Square root of 9 I know is plus or minus 3. Square root of 2 I can't do anything with. And square root of negative 1 is I. So this is plus or minus 3i square root of 2. Right? So that goes where the square root of negative 18 was. Plus or minus 3i square root of 2. Add 1 to both sides. And I get x equals 1 plus or minus 3i square root of 2. And I have 2 imaginary solutions, no x-intercepts, and a beautiful answer. That looks like another language. All right, and that's it, okay? So, all right, so for your homework, there was a few different skills that we were practicing. First, we were making sure that we could simplify radicals that had a negative in them. So there's a couple skills. Do we know how to pull out the negative? Do we know how to break down a radical if it's not a perfect square? Then we were adding and subtracting when we had I. So do we know how to combine like terms when we have I? Do we know what to do when there's a negative in parentheses? Then we were multiplying with I, so then you're going to end up with I squared a lot. So do you know what to do with that I squared? And then multiplying a little bit more difficult when you have 2 binomials and you have to FOIL, right? So do you know how to FOIL when you have I, and what happens to the numbers after you do? Okay, so we'll start at the beginning where we're simplifying radicals. So 1 through 4, where you're just breaking down radicals, right? A couple different skills in here in one. Anybody want to see any of these? Yeah?
Can you just do one really quick?
Sure. Why don't we do this one? All right, so remember the principle here is, like, even if I just had square root of 150 and it wasn't negative, I still would do some work here because I would think to myself, okay, I know it's not a perfect square, but I could maybe break it down a little bit. Now, what I mean by breaking it down, basically, you know how, like, if you had, let me just come up with a random example. If you have 12, you can rewrite that as 4 times 3, right?
Yeah.
Well, the same thing is true if you have the square root of 12. You can rewrite that as the square root of 4 times the square root of 3, right? That times that is that. So you can change it to that. Now, why do that? Because I couldn't do the square root of 12, but I can do the square root of 4. Square root of 4 is what? Plus or minus 2. And then I can't do the square root of 3, so that just comes down. And I get a more precise answer than the square root of 12. This tells me more information. Tells the person more information, right? So it's worth doing that. It's worth simplifying it. Now, if you have a negative, there's a little bit more that you need to do. So you start by saying, well, let me just first get rid of that negative. So can't really get rid of it, but I can pull it out. So 150 times what is negative 150? Negative 1. And now I've pulled that out so I can work with this, right? And then when you can take 150 over to the side, or you can do it right here, and you ask yourself, well, are there any perfect squares that go into 150? For, I don't know, 9, 16, 25, right? Just look down the list. 25. So 25 goes in 150. Think about it. If you had $1.50, can you get quarters out of that? You get 6 quarters, right? So 25 goes in 6 times. So now I'm going to say, well, actually, this is the square root of 25 times the square root of 6 times the square root of negative 1.
Is the negative 1 always scalar?
No. Once you've broken it down, now you evaluate each piece. So you look at this one, and this one, and see if you can do something with them, right? That was the whole idea of breaking it down. Square root of 25, can I do something with it? Yeah, what does that become? What is the square root? Plus or minus 5, right? Square root of 6, can I do anything with that? No. So I just bring it down. There's nothing else I can do other than bring it down. And the square root of negative 1, we learned we can rewrite as I. So, okay, you basically have your answer. The one thing I will say is that this I on the back, students tend to make it look like this, and that's not right. Like, it's not under the radical. So I would say you're better off putting it right here next to the 5. So I would take the time to say plus or minus 5I square root of 6. And that's the way you'll see it written more often. Okay? Question?
Would we have to show this kind of work on a test?
So, no, you can't just type this into a calculator. It'll give you a decimal. Actually, it would give you an error because it's a negative.
No, it works.
Yes, you will have to show this. You can't use your calculator to do this. Okay? Does that make sense? Yeah.
How did you do 5?
Because the square root of 25 is 5 times 5. So you just think what times itself would give me that? 6. Well, 6, I can't break that down. That breaks down into 3 and 2, and neither of those are perfect squares. So so you just leave it. The reason we broke down 150 is there is a perfect square inside of it, 25, right? So you got to kind of know your perfect squares in the red boxes over there. All right? So that's the process. Does that make sense? Okay. Now, a lot of times when you do this, it's in the middle of a problem, right? It's like you got an answer that's that, and now you have to do a little bit more with it. And this is the skill. Okay? All right. 9 through, or I shouldn't say 9, 5 through 8, where you're adding or subtracting. Anybody want to see any of those?
Can we do 3 up?
Oh, you want to do it? Okay, so I think the reason that 3 was tricky is because you did this, right? Right? Pulled out that. And then you took 70 over here, and you were like,
35, 2, 7, 10. I don't know what it is.
yeah, 7 and 10, 5 and 2. There's no number that shows up twice. Like, it's not like there's a perfect square in there. So what does that mean we do?
Just leave it as is, but take out the negative.
So I just say I square root of 70. And that's as far as I can go. I'm done. There's nothing inside of it that was a perfect square. Yeah. Yeah.
Is it just I is 70? Or I?
Well, actually, it would be plus or minus. Any other questions on the front? 7? Okay, so number 7. Okay, so one thing I will note before we do this is I've noticed in a few different classes that people started foiling here. because you're so used to parentheses, parentheses. Oh, that's the FOIL situation. But think about it. FOIL is when you're multiplying, right? This isn't multiplying. What's it doing? Subtracting, right? So this is not a FOIL. This is a subtraction situation, right? So what you would want to do is think to yourself, okay, what happens when I have a negative in front of parentheses? There's it's like there's a negative 1 right here, and that gets distributed, right? So that means 12 plus 9i, and then negative 1 times 2 is negative 2. Negative 1 times 7i is minus 7i. So you just take that negative and pull it through the parentheses. Does that make? I don't know why that 1 made it. Yeah, so anything inside, if there's a negative on the outside, it's for everything inside. So everything flips its sign. Now, once I do this, I just look for my like terms. 12, negative 2, 9i, minus 7i. Bring together what we can. 12 and negative 2 is 10. 9i minus 7i is 2i. And then we're done. Okay, just like if it was x. Any other problems on the front? All right, the back is where we're multiplying, so a little bit trickier because you get that I squared thing a lot. Does anybody want to see anything 9 through 12 before we start foiling? 12? Okay, so 12. If this just said a number on the outside, what would you know to do with that? Starts with a D, distribute, right? So it's not a number, but it's still the same principle. Something on the outside, you distribute it. So this gets distributed to everything. So write it out. Say, okay, negative. Uh-oh. There we go. Negative 4i times, what's the first thing it gets multiplied by? Negative 8. And then plus negative 4i times I. Getting a delay here. Okay, so we do each of those one at a time. What's negative 4 times negative 8? 32. And then there's an I there, right? And then this one would be negative 4 times 1, so negative 4, and then I times I. Negative 4i squared. And in fact, if it's plus minus, you could just write minus 4i squared. Now, this is where you needed to remember, what is I squared? I squared, it's one of the things we learned last class, I squared equals negative 1. So if anytime you get an I squared, you put a negative 1 in its place. So this becomes 32i minus 4 times negative 1. What's negative 4 times negative 1? Negative times a negative is a positive, right? So 32i plus 4. And then we do want to say 4 plus 32i because that's the proper way to write it, with the I second. Okay? That I squared is the key. If you don't know what to do with that, you kind of get stuck. All right?
Wait, I thought. Okay, no, wait. Oh, I switched it. I put 4i on 32.
Sorry.
Why wouldn't it be squared at the end?
Why wouldn't this be squared?
No, like the final answer, so you see 4 plus 32i. Why wouldn't it be 4 plus 32i squared?
Because this 32i came from this, and it was just I here, but no I here, so it didn't get squared over here. This became squared because I had I times I, and that made it squared. And then we knew that I squared is actually negative 1. So we plug that in instead. All right? Let's move on to the boxing questions, or the foiling questions, actually, because I think FOIL works better here. Which ones, if any, do we want to see?
Can we go 13?
13? 13, okay. All right, let's talk about 13. All right, so with this, we FOIL, right? We use the word FOIL all the time. And I asked somebody today in my other class, what does FOIL stand for? And they're like, I don't know. We just say the word FOIL. Don't forget what it stands for. That's why it's called FOIL, right? What is it? Outer, inner, last. Like in the word are the directions of what you're supposed to do, right? So don't forget what it stands for. First, outer, inner, last. Now, first means this times this. Now, a lot of times, if you have like x times x, you just write x squared. You don't have to write out x times x. But here, I think you should. Write out the multiplication. Say, okay, that's -2 times 6 plus, and then I do my outer. Oops. Okay, that's -2 times -4i. Then I do my inner. That's -8i times 6. And then I do my last. That's -8i times -4i. Okay, so there's a lot to write out, but it's beneficial because then you won't make any mistakes when you have to simplify. Because right now, I know I need to do this math, do this math, do this math, and do this math. I just need to bring everything down for what it is. So each one of them on their own isn't that bad, but altogether it's like in your head it's too much. So -2 times 6, what's that? -12. -2 times -4i. It's plus 8i, right? -2 times -4 is plus 8. Okay? So, and then -8i times 6. -48i. And then -8i times -4i. So there'll be positive 32, and then I squared. Okay, so we've gotten a little simpler now, right? Now there's two things you're going to be able to do right away here. Question?
Wouldn't that be positive 48i?
It is positive. So negative times a negative is positive, I squared. Yep. So there's two things that we can always do at this step. Anybody know one of them? Go ahead.
Combine my terms.
Yep. So this is just like if I had 8x minus 48x, I could bring those together, right? 8i minus 48i, you can bring those together, right? What is 8 minus 48? Minus 40. So I have minus 12 minus 40i, and then plus 32i squared. Now, there's another thing I can do at this point. Just like the last problem, when I get this, I know what to do.
Solve I squared.
I squared is what? -1. So I'm going to replace the I squared with -1. So -12 minus 40i plus 32, and then times -1 instead of I squared. What is 32 times -1? -32. So -12 minus 40i minus 32. And then there's one more thing we can bring together now. -12 and -32. What is 12 plus 32? Yep. So -44 minus 40i. And that's as far as you can go because you can't combine those two things. Okay? So that's, I know those are a lot, but if you do them piece by piece, they're not that bad. Okay? You just got to remember a couple things. These are like terms. I squared is -1. Okay? Treat it like it's x and you'll be okay. All right. Question. Anybody not know what to do with 14? This one.
Just separated?
Yeah. So if you knew how to do 13, you knew how to do 14. And you just didn't know it yet. Because all you had to do with this was rewrite it as 8 minus 2i times 8 minus 2i. And now it's just like that problem. Right? Just remember what squared means. It means that something times itself. Right? So that makes it just like that problem, and then you can go from there. Okay?